Hello, everyone, and welcome to the bonus problem lecture for the section 1 of the Abstract Modern Algebra lecture series. So let's look at this bonus problem. We have a typist wants to acquire a set for the group under multiplication modulo 154, and he wants us to provide the group for him or her, whoever the typist is. So, the multiplication modulos, they have a lot of real world applications. So this is going to be a big group to list all the elements out. So it would be easier if we just did a Maple mathematical program or any kind of mathematical programming software to list out this group for the typist. So that's what we're going to do. We are going to use the Maple mathematical programming software and write out a code, write out a program that can give us this group. All right, so here we are in Maple, and we are going to write the program to output the group of all prime integers less than an integer n that is under the multiplication modulo n, or in other words, u of n, or we will denote it as u underscore n for programming, because when you usually have a variable inside parentheses, Maple will think of it as a function, which is not what we are doing for this specific notation. So I just included a comment to describe what this program is going to be. Usually a good practice to do when you do write a program. So let's first put in a restart command, because if we have to restart the program again, start from the beginning, it can erase whatever we've did before. And then we will do with number 3, and we will include this to include some additional functions, because we're going to write out the divisors of our value of n, which is 154 for this problem. Then let's define n. Let's keep it lowercase. And that's going to be equal to 154. And this is our integer for the group. And this is the only value that can change. The rest of the program doesn't need to. And then let's list out the divisors of our integer n, because when we write out our group u of n, we can look at the divisors here and compare them, and they can be a good way to validate what we are doing in this program. So let's define a variable x as the sequence with the variable a, where a is 1 to n minus 1. So this is going to define the integers from 1 to n minus 1. And there we go. So for fun, let's include z of n in this program as well. And if you recall, z of n is just the group of integers under addition modulo n, because in case you ever needed those, you could have them in this program too. Now, let's find our u of n. So we are going to define that as an empty set to begin, because we need to acquire our prime integers, and then we can add them into this empty set u of n. So what are we going to do? I'm going to write out or comment out what we're going to do here. So we're going to use a for sequence with a do loop and if loop to identify the integers of x that are prime to n. And I'm just going to add another comment. Use shift plus enter to space code out on a new line. All right, so let's start our loop. And the reason I included that extra comment, shift plus enter to space code out on a new line, is because of the way Maple programming is that you could technically write your entire sequences and loops out on one line, but to make it easier to read, we'll try to space them out on different lines while keeping our sequences and loops combined. So let's start with for x from 1 to n minus 1 do. I'm going to write out this loop and then I'll go back and comment what's going on here. So we have GCD x of n equals 1, then u of n equals u n union x. Then we will end our if loop and end our do loop. Okay, and then we have u of n, so let me go and comment what's going on here. So here we are defining where on x we are looking at. Because when I was trying to write this program, for some reason when I just stated x as our condition, for the for sequence, the program wouldn't run right for some reason, so I have to redefine it as the set of all the integers from 1 to n minus 1. And then here we are using the IGCD function to define the greatest common divisor we are looking for, which is 1. And then here we are using a union set operation to put the prime divisors into u of n. And then these are pretty self-explanatory. They're ending the loops. So now, because it's in a loop, it's not going to display it. We will just have to type it out here to display u of n. And these are all the prime integers of 150 that are relative to 154 and our group, u of 154. And you can just look back up here at the divisors and see, well, don't see any multiples of 2, don't see any multiples of 7 or 11, and et cetera, et cetera. So we should be good for this program. And this program is nice because you can change n to be whatever value you want it to be. Just make sure when you run the program again, you will have to start at the top and then just press enter to run through everything that you have programmed in here. So, all right. That is it for this bonus problem. Thank you guys so much for watching. Hope you enjoyed this video and that this is helpful to you. Thank you.